Hey folks, can everyone hear me okay? You can respond on the chat. Hey folks, can everyone hear me okay? You can respond on the chat. Hey folks, can everyone hear me okay? You can respond on the chat. Hey folks, can everyone hear me okay? You can respond on the chat. We're just going to wait until the top of the hour to get started. Okay? You can respond on the chat. Don't want anybody to feel like they missed out, even though they were on time. Idaho, nice. We're just going to wait until the top of the hour to get started. Okay? You can respond on the chat. Don't want anybody to feel like they missed out, even though they were. Okay, hopefully we got rid of that echo. Minnesota, hello. And Hawaii. Gosh, I wish I was there. Ireland. Arizona. Good to hear I'm sounding fine. This is my first time using this live streaming software. It's called Streamlabs OBS. It's free and it seems like it's pretty nice. Hello there from Maine. So we're going to do the format. I'm going to start out with a quick chat about feeds and speeds. We're going to talk about sort of not just feeds and speeds, but also some other types of things, basically good techniques and tooling that are important to getting good results. It isn't just feeds and speeds, in other words. I'm going to talk a little bit about the differences between how CNC router and hobbyists with lightweight machines should be approaching feeds and speeds. And then I'm going to give a demo of GWizard's new easy mode, which is really aimed at the beginner audience. After the demo, I'll throw it open, and you'll be able to ask your questions, and I'll try to answer them as best I can. So we'll have both a sort of a pre-programmed part of this, as well as a free format where the audience can kind of guide what we're going to talk about. I do want to stay focused on sort of the feeds and speeds theme, but doesn't have to be beginner if you have a question. So I hope you have got your questions ready to hand for when we start on that. I've got a few that people mailed in as well to get us going. And I hope everybody is well today. The weather here is absolutely gorgeous. Been keeping our heads down a little bit to avoid the corona. But other than that, life is generally good, and I hope it is for you too. Hello from Wisconsin. Hello, Portland, Oregon. Good to have you on board. Here for me is Santa Cruz, California, just south of Silicon Valley. Happy little surf town. We sit right between Silicon Valley and Monterey, California. Delray Beach, Florida. Boy, I would bet the weather's good there. One thing that's a little bit odd about this whole experience at this end is there's a pretty long delay from when I say something to when it comes out the other side of YouTube. So I had to turn off all of that, or I was just drive myself crazy with that delay. Other than that, things look like they're working good. If it looks like I'm sitting here kind of in darkness, I sort of am. My office here for CNC Cookbook has no windows, and I keep the lights dim, and that's just so I can really be focused on what's going on with the computers. And my workshop is much different, very brightly lit, because that's important for CNC work. Hello, Victoria, Canada. I see a few names that are familiar from email as well. Eagle, Idaho. Nice. Yeah, just a couple of minutes left and we'll get started. Northern Virginia. I am recording the session, so it'll be available. I will send out an email with the link when it's ready, so make sure you're on our mailing list. Oh, here we go. Sandia Park, New Mexico. Nice. Welcome. Nova Scotia. Is it cold there, Vincent? Sounds like a place that would be cold, but I honestly have never been. I'd like to visit sometime. I hear it's beautiful. Thornton, Colorado. I lived in Denver for a while, Lakewood to be precise. The Philippines. Welcome. Welcome. Belgium. Welcome from Belgium. Oh, there we go. Okay, I got a request to touch on 3D surfacing. Let me just make a note, because that's definitely a popular topic. You can sing out on the live stream anytime you have a topic or question you want to make sure that I cover. I will scroll back when I get ready to go. Long Island, Big Apple, New York. Nice. Houston, Texas. I went to school there at Rice. And the Czech Republic. Welcome. Kansas, South Carolina. Portland. In GWizard, if not slotting, is side milling assumed? Yes, although it'll also give you feeds and speeds for plunges, ramps, and helixes. Brett, I got your question in my archives here. We'll get to it at the end. Lithuania, hello there. Depth of cut versus tool life. We'll talk about that. Okay, we're a couple minutes past the starting time, so let's go ahead and get started. I think it's time. Welcome to our Feeds and Speeds for Beginners live stream. We're going to try to go through what I think of as everything a beginner should know to be ready to get started with feeds and speeds. And I'm going to also do a quick demo of GWizard's new easy mode, which is perfect for beginners. And then we're going to throw it open to questions. And I've already logged a few here. I will definitely scroll back and make sure I haven't missed anybody's questions. when we get to the Q&A section. And so let's take it away. So we all know feeds and speeds are important. We know what happens if you don't have good feeds and speeds. You know, if you're lucky, your tool life is poor. If you're less lucky, you're breaking tools. The finish on the part is lousy. The job runs a lot slower than it needs to. And if you're worried about precision, you may be having a hard time holding your tolerances. Can feeds and speeds fix every one of these problems? And I have to say they can't. Good feeds and speeds help tremendously, but I find particularly with beginners, they're just the first step. There's some other key things going on that if you don't pay attention to them, it can look like you're having bad feeds and speeds when in fact it's a different problem. So let me just quickly run down sort of the list of things to be on the lookout for and to try to learn more about in addition to feeds and speeds if you're a beginner. First up is work holding. You've got to make sure that the piece you're cutting is held down tight, because you're going to run this cutter into it. It's going to exert force on that part, and if it vibrates, that's going to be bad for your surface finish or your tool life. So part of what you're doing is just trying to hold it down tight enough it doesn't vibrate. If you hold it too tight, the part may deform, right? You could cause it to bow up, for example, and that leads to all sorts of problems. And in particular, one of the worst things that I see happen to beginners is they didn't get the part clamped down well enough, and it moves while the cutter is in the cut. And that will usually just flat out break the cutter right then and there. So be on the lookout for solidly supporting, holding, and clamping your work with an eye towards making sure it can't move, that you're not getting excessive vibration, and that you're not overly forcing the part by pinching it from the sides or whatever to the point that it's bowing. A second big area is tool holding and machine issues. Beginners and hobbyists in particular have machines that are not built to the same tolerances as an industrial CNC. And so you can have what's called runout. Think of runout as, if this is your tool, instead of it spinning true along the axis, maybe it's slightly cocked and it's doing something like this. And I'm exaggerating the heck out of that to make the point, but that's what runout is. And even a little bit of runout can really adversely affect your cut. It's something that you can measure, and there's articles on CNC Cookbook that talk about how to measure it. Let's assume you don't have any runout. It's one of those things where it's probably not your problem. But if you find yourself breaking tools a lot, it's something to go check into. Pull-out is another issue where your tool is being held by a collet of some kind, and the forces of the cut literally pull that tool a little bit out of the collet. And now suddenly you're taking a deeper cut than you had intended. And again, that can lead to, if nothing else, you're not going to be cutting the cut you thought you were. But worse, when you suddenly go deeper like that, you may break the tool. Lastly, as far as tool holding, rigidity and vibration are issues there too. Rigidity is so important when you're cutting with a CNC, and vibration is just never your friend. In the worst case, it makes a really nasty noise that's called chatter, and it'll really shorten the life of your tools. Next category of issues are coolant issues, and not just coolant, but chip clearing. I always kind of cringe a little bit when I see chips really piled high and the cutter's down in the middle of a big pile of chips trying to cut, because you're making that cutter's job that much harder. It's got to push new chips past all the old ones to be able to get anything done. The other thing about it is certain materials, and aluminum is probably the worst offender here, have to have some kind of lubricant or the chips will weld onto the cutter. you know, there you can sort of get away without lubricant a little bit if you're taking really light depth of cut and you got enough air or whatever blowing on it to clear those chips before they can weld. But you're kind of living on borrowed time with that. If you're going to do much aluminum, you know, best to rig up some kind of a mist and keep it lubricated because it makes a huge difference. Another category, and again, I see this a lot with beginners, is using dull, cheap, or otherwise bad tools. I was talking to a gentleman the other day, and he was not happy with the results he was getting and wondered if he shouldn't do some kind of a tune-up on GWizard to get better results. And he sent me a link to his tool, and he literally was spending $1.50 for a 1/4-inch end mill. And I gotta tell you, I don't know what that thing was made out of, but that is probably not going to give you ideal results to spend $1.50. You need to get a more reputable cutting tool to get good results. In the realm of interesting, again, I talked to literally thousands of CNCers in the course of a year, and every now and then I'll get somebody they're having a terrible time, and then they discover when I have them check it that they were running the spindle backwards. They got the connections backwards or whatever, and the spindle was going backwards relative to what the cutter needed. The last one I'll mention is a software issue, and that is how your CAM software enters the cut. It doesn't matter an awful lot for soft materials, but the harder the material is, the more it matters. And in particular, if you're going to try to cut something like stainless steel or titanium, heaven forbid, you need to be really, really knowledgeable about how you're going to enter that cut, because those type of really hard materials are going to have a tendency to chip the cutter on the way in if it doesn't enter properly. And once you've chipped that cutter, things are just going to go downhill in a hurry from there. So that is sort of a set of non-feeds and speeds things to have under your belt and to be aware of that can be really helpful to you. All right. I want to talk briefly about the differences in CNC routers and hobbyist lightweight machines versus industrial CNC machines. So let's start with routers. These are generalities, but they're true more often than not, and that is you're working with faster RPMs. Often you can't go slow enough for some combinations of cutter and material with a CNC router, because maybe they'll only go down to 10,000 RPM or 7,000 RPM. They don't go from 0 to 24,000 RPM or whatever it is. And so there's a set of techniques that you'll need to develop in order to deal with that, to be able to keep the speeds up fast enough for what your machine's capable of doing. Another issue with routers, they call them gantry machines because of the way they work. They have huge travels, generally not as much Z travel up and down, but huge X and Y travels relative to a more conventional milling machine. But they're also way less rigid, and so we're getting back into that realm of more likely to vibrate or deflect. The fact that they have less Z travel sometimes changes the nature of the work we do. You're more likely to see a CNC router cutting out basic shapes from a big piece of plywood, for example. It's something they do exceptionally well. If we talk about hobby machines versus more industrial machines, again, let's start with the RPMs. They're all over the place. Typically, hobby machines either are very slow on the RPMs. Maybe they go from 0 to 3,000, or they've got ranges where you have to select gears or belts, or they're using a CNC router style spindle and they're very fast. And so you got to be able to navigate around sort of the dead spots where you may be thinking, well, my feeds and speeds need to be here, but my machine won't go there. Hobby machines typically have slower feed rates. If you had unlimited feed rates, you may be looking at a cut that, on an industrial machine, it'd be going 400 inches a minute. But, if your machine will only go 100, you got to know, what am I going to do about that? They have lower horsepower. That generally means smaller tools, smaller diameter. Smaller tools are more delicate, but in their favor, they use less horsepower and they go faster. And they're cheaper to buy too. That's no small thing either. If we get too large a tool, we start dealing with issues of the motor stalling, right? You can stall the spindle, you can stall the axis. Either way, it's generally not good for the cutter, and you'll often break a cutter when that happens. They can have slop and backlash, run out. All of these things can come along. But now here's the thing. If you can get the right feeds and speeds and a little bit of finesse on your technique, these hobby class machines are capable of amazing stuff. Just unbelievable. I've seen tiny little machines make the most intricate and precise parts. I've seen them cut, really, really nasty material like titanium, and you can really get good results from them. It's a little bit harder. It takes a little bit more care and patience, but it's entirely doable, and it's way worth learning how to do that. Any questions to this point? I don't see anything major popping up, so I'm gonna plunge ahead. So one thing about feeds and speeds is we did a survey one time where we asked folks to tell us what's hard about learning CNC, and here's what they told us. And I was actually quite surprised by it because I think about what's hard for me, and it's often like learning the latest new CAM program or whatever is hard. But what I got back from my audience was the number one hardest thing to learn was actually feeds and speeds, along with issues that are related, like how do I choose the right cut depths and widths. And I think I've already got at least 3 different questions teed up about that. And how do I choose the right cutter? That, by a wide margin, was the hardest thing for them in CNC. Number 2 was sort of the operational details of setting up for a job. And number 3 was work holding. So it's worth keeping in mind that feeds and speeds are hard. And, a question that comes up is, well, why is that? What makes it so darn hard? I've seen stuff that suggests it doesn't have to be hard at all. And that's part of the problem, because there's a bunch of myths about feeds and speeds that give people the wrong idea, and they sort of go off with that. And it's a bad journey. That's all I can say. It's just a bad journey. So let me cover kind of the top 3 myths that I see out there about feeds and speeds. Myth number 1 is, if I go slowly enough, everything will be okay. And there's 2 big things that happen that make it not okay. One is, if you go too slowly, your cutter will rub. And this illustration here tries to explain why that happens. Think of this blue piece as the edge of your cutter under high magnification. And if things are working right, it's going to slice off a chip, right? That's what's happening here. It's slicing off a chip. As we go slower and slower on our feed rate, though, what happens is that chip gets thinner and thinner. And at some point, the center line of the cutter, is actually above the surface of the work, and you're no longer getting underneath the chip and slicing. Instead, you're kind of plowing along, right? It would be more like filing than slicing. And when that happens, your tool is rubbing. It's going too slow. And when it's rubbing, right, I hear rubbing and I think friction, and that's exactly the right thing to think. Your tool's getting too hot. And as it gets hot, it softens the cutter, which makes the cutting edge duller, which makes the problem even worse. So if you go too slow straight up, you're going to run the risk that you're rubbing. And that's very bad for your tool life. Here's another really weird thing that can happen. It's called chip thinning. You're looking at this round circle is your cutter looked at from directly above as it's going into a cut. And you've got two different thicknesses. And if you're cutting half of the cutter's diameter or more, then you're getting a chip that's like the red and the blue combined. And what that means is your chip is what you expect. But the shallower the cut, the thinner your chip is going to be. And you can kind of see that geometric effect here with this blue area. And remember, what happens when the chip is too thin is you get rubbing. So with chip thinning, even just the idea that, well, I need to take a shallower cut, it can push things into rubbing even though you're going at what look like respectable feeds and speeds. So those are just two ways that things can go wrong if you're thinking, I just need to go slower and everything will be okay. Myth number two, I hear this one a lot. You can judge feeds and speeds by ear. There's a little bit of reality to it. You can hear really bad feeds and speeds. And if you hear a cut and it just doesn't sound right, you really should stop and see what's going on there. But what you can't do is you can't hear the difference between so-so and excellent feeds and speeds. A lot of these things, you really can't hear a difference in sound when the cutter starts rubbing, or when chip thinning starts to set in, or when you get too much tool deflection, which is another problem that you can have. You can't hear those things. They sound pretty much the same. And so I like to tell people, listen, if you could hear good or bad cuts, you would be able to buy sets of CDs that were ear training for machinists. And when you went to apply for a job at Boeing, they'd put the headphones on and go, okay, you need to pick out all the good cuts and tell us all the bad cuts by the sound. And nobody does that. Because the reality is you can only hear really bad feeds and speeds. You cannot hear sort of a little bit bad feeds and speeds and tell the difference between that and really good feeds and speeds. So don't count on the idea that you can hear it. Last myth I want to talk about is all it takes is a simple spreadsheet. Here's the reality. If that's all it takes, A, I wouldn't have a business. But B, all of these crazy things that I've talked about, believe me, I barely scratched the surface about rubbing and chip thinning and all this good stuff. It's complex math. GWizard considers almost 60 variables when it's doing a feeds and speeds calculation, and they're all important to what's going on. The simple little equations you find in a machine shop textbook, they don't begin to cover all that's going on with feeds and speeds. Now, there is good news. And, lest you be scared away from CNC by the idea of higher math, with a good feeds and speeds calculator, you don't have to know any complex math. That's what the calculator's there for, is to deal with that stuff. And it absolutely will. So next thing I want to do is give a demo of GWizard's new easy mode, which is perfect for beginners. But before I do that, I want to see if there's any questions about the areas I've just covered. Hello, Bucharest. Thanks for joining. Okay, flooding and misting. Yeah, we'll get that question when we get to the Q&A. Excellent question. Okay, let me get over to GWizard next. Okay, now here I'm going to show you, it'll switch over in just a second to showing you GWizard. This is what the screen looks like when it first comes up. And there's a good comment out there. The problem with CNC is that it takes the feel out of how a cutter wants to cut. If you ever get a chance to try some machining on a manual machine, it's way worth it because the gentleman's absolutely right. There's a lot you can feel going on in the hand wheels of your machine that you can't tell is happening on a CNC. Those motors are absorbing all of that and they're not telling you what it feels like. Okay, here's GWizard just as it comes up out of the box. And as I mentioned, I want to show you easy mode. GWizard is a power product. It's the best in its class. it does all kinds of things that no other product does, and we're constantly adding new things to it. But it can be a little bit overwhelming for beginners. So we put in recently, if you go to the Setup tab, there's an Easy Powerful button. And if I click Easy, things get simpler in a hurry. A whole bunch of these tabs disappear. And as we go on to each tab, they're simpler as well. So what I want to do here is I want to take you through some simple feeds and speeds calculations and just show you how easy it can be. And in GWizard, there's a simple rule that's designed to help you not get lost. And that simple rule is you always work left to right, top to bottom. So you just start scanning to find what you need and enter it as you go, and you'll eventually get everything filled out that needs to be filled out, and away you go. Now, I like to have people start with what we call the CADCAM Wizards. That's this very leftmost tab. CADCAM Wizards are kind of interesting. They are all about thinking about feeds and speeds in a radically different and much simpler way. And let me illustrate what I mean by that. I'm going to bring up very quickly here a shot of Fusion 360, very popular CAD-CAM program from Autodesk. It's available free to hobbyists. I like the program. I use the program. It does have a pretty steep learning curve, and it may be worth your while to look at some simpler programs. It's also more focused on precision mechanical parts than more artistic work like sign making. So if your thing is sign making, you're probably going to be happier with products like Aspire from the Vectric people to be able to do those sorts of things. Anyway, if I'm going to make this part, and I'm just talking about cutting out this center cavity or pocket, I've got to answer a lot of questions, right? I've got to basically tell the CAM software all these different things. It wants to know what's my spindle speed, surface speed, ramping speed, cutting feed, lead in, lead out, endless questions. And there's 5 tabs worth of these questions. So one way to think about feeds and speeds is, the physical way, here's what my cutter needs to do to be happy. And the other way is, who cares about all of that? I just need to get these darn questions answered so I can get my G-code program and make my part. And that is what this CAD-CAM Wizard part of GWizard is all about. It's really focused on the problem the way your CAM software thinks about the problem. And as I said, we go left to right, top to bottom. So I start out, I want to choose a machine. There's a variety of different machines here. Let's stick with the Tarmac. It's a nice hobby class machine. I choose a material, right? And I don't know, let's say I'm going to make something out of some hardwood, okay? And then I choose what type of feature, what's the shape I want to cut. And my choices are, I can do a pocket like that cavity I just showed you. I can do a 3D profile, and it's showing you a little icon. 3D profile is, something sticking up. I'm cutting the sidewalls. Or it's also, maybe I'm doing that business of cutting a part out of a piece of plywood if I click the part cutout. I could be making a hole. Holes are by far the most common thing that we ever do on a CNC machine, and we have lots of different ways to approach hole making. GWizard will even figure out things like threading with taps or thread mills. It'll do interpolation, interpolated holes, spot drilling, all of that good stuff. We may be looking to cut a generic 3D surface, right? Like maybe I'm going to engrave a face into a plaque or some other sort of arbitrary organic shape. That's called 3D surfacing. And then last but not least, maybe I'm going to face mill, which is another type of surfacing. Maybe I've got a CNC router and I need to run my spoil board cutter to make sure my spoil board is flat or the top of my part is flat with a face mill. So those are the different types of operations that you can perform. And you pick your operation. And then again, you're going left to right, top to bottom. For this pocket, I want to come in and I don't know, let's say it's going to be a 1/4 inch deep, and the minimum inside corner radius is 1/8 of an inch, and I want to go ahead and have a finish pass here too. I can do a chamfer if I want to, but let's just leave that. That's really all I had to tell it in order to get an answer back. And let's hit recalc and get our answer back, right? And what I wind up with is I've got roughing and I've got finishing here. I've got a tool selection. It told me what the right tool to use was. It told me my cut depth and my cut width, you know, what they should be, my RPM, my feed rate. It's all right here. And it even told me that, at least for this particular type of thing, my spindle RPMs are maxed out. That, by the way, is good for tool life. But if I had a faster spindle, I could make the part faster. So it's giving me that little bit of insight. And it did all of this for me by using some artificial intelligence learning algorithms to go out and test 651 different scenarios. So really, really powerful, but at the same time, very easy to use. Let's go ahead and drill down. Okay, if we drill down, we go to the Feeds and Speeds tab, and it carries over all of these different things. And we can see that, in fact, GWizard has really maxed out our Tormax capabilities to cut this hole, which is fine. You know, we want it to go as fast as it can, but if we want to slow down, that's not a problem. I can dial my my tortoise hair slider down a bit, right? Cut it down to where things are a little bit less crazy. I can dial down my RPMs, right? And you know, maybe this is more comfortable for me if I'm starting out, or I can you know, pedal to the metal. Here's how aggressive I can be, so here's how aggressive I will be in terms of cutting this part out. I want it to go as fast as it possibly can go. Now, as a beginner, it may not be obvious to you which buttons to press to get some type of a change to happen here that you're interested in, whether that's just being more conservative or whatever. So GWizard has a feature that we call the cheat sheet. And it's pretty darn handy. With the cheat sheet, you get a list of things you can do, okay? And it goes through that list, and you choose what you want. You want longer tool life. It gives you some choices of what you have to do. You know, set the tortoise hair slider further left. Reduce RPMs. Those are the types of things that you want to do, and it gives them to you in the preferred order that you would do it. So it's kind of like having a experienced machinist sitting there at your shoulder that tells you exactly what you need to do in order to get the results that you want. Okay? GWizard's got a tool crib. You know, I've got this tool all dialed in here. I know if I've used the tool once, I'm going to use it again. So maybe I want to send it over to my tool crib, right? And so I'll pick the crib I want it to go to, and I'll, you know, fill in these different results here so I can describe it. I don't know, maybe this is my favorite 1/4 inch end mill, whatever I want to do there, paste it in, and now I have my tool crib tools. And what's nice about this is, you know, the next time I want to use a tool, I don't have to fill out all the data. I just go in here and I choose which one I want, and it fills out the data for me. Quick and easy. Those are really the capabilities that you need to get your basic feeds and speeds, maximize your tool life, and be off and running as a beginner. And that's all that the easy mode shows. When you're ready to get sort of unleash the full power, click the powerful button, and all these additional capabilities will show up that you can use. But you know, when you're just starting out and you want to keep it simple, use easy mode, and it'll be simpler. Okay, let's see. I think it's about time to turn to some questions. So let me just organize that a touch. make sure I don't miss any. Hello, Cedar Rapids. My mother was from Cedar Rapids. I'm just making some quick notes before I jump into the questions so I don't miss any questions. Almost there. Okay, let me dive in. So I've got some questions about mist versus flood versus both. What's their impact on feeds and speeds? Let's talk about coolant real quick. I've got articles to this effect on CNC Cookbook, and I've done videos for Cutting Tool Engineering magazine about coolant, but let me just say it's a bit unfortunate it's called coolant because that's almost the least of its functions. Its most important function is clearing chips. And, you know, if you want to just look at that function and that function alone, clearing chips, imagine a really, really powerful air blast versus a trickle of flood coolant. That trickle of flood is not gonna clear chips to speak of at all, and the air blast is going to be much better at that job. In terms of mist versus flood, again, if I've got enough air pressure behind the mist and the flood is barely a trickle, it's kind of odd to talk about flood as being a trickle, isn't it? But it happens that way on hobby machines sometimes. The mist beats it. It's like, which one is better at clearing those chips? So you could see that with your own eyes. And by the way, once you get, I tell people, be paranoid about clearing the chips. Once you feel like it's paranoid, once you feel like it makes you nervous, if you see them piling up around the cut, you'll get more attentive to things like how well the coolant is aimed at the cut and whether it's really doing the job you need it to of clearing the chips. So mist and flood, those are kind of the trade-offs for chip clearing. Function number 2 of coolant is this lubrication thing I talked about, particularly with regard to aluminum. Aluminum wants to weld itself to your cutter. And the role of the coolant there is not just chip clearing, which, if the chip is moved away very quickly, it doesn't get a chance to weld, but also if there's lubrication so it can't really rub up against the cutter all that hard, then that helps. And here, the story of mist versus flood is a little different. Obviously, flood does a better job of putting a lot of lubrication onto the cutter and the material, even if it isn't very high pressure, than mist. But mist can be good enough. Just make sure you're not too chintzy with the amount of mist you're putting onto the cut, or you can start to get some welding. Particularly, think about cases where you can't see that much of the cutter because it's way down deep in a slot or something. Those are tough cases for the coolant to do its job. The last thing coolant does is cooling. Most of the time, the cooling is a function of having good feeds and speeds, which result in most of the heat being in the chip, not in the actual workpiece, and certainly not in the tool. So if you've got your feeds and speeds set right, the chips carry away most of it, but not always enough. particularly certain materials. Titanium, for example, is a lousy conductor of heat. And so you really need some liquid coolant on titanium, often on stainless steel and other types of difficult materials to help carry away some of that heat. So that's kind of the story when it comes to flood and mist. Let me see what other questions I've got here. What is G-code? Well, G-code is the programming code that your CNC machine understands. Your CAM software outputs G-code. Some people handwrite G-code. It's not that hard to do. And what are called conversational wizards can also generate G-code. But what your machine wants to get to tell it what to cut is called G-code. I got a lot of questions about depth of cut versus step over, depth of cut versus tool life. These are interesting questions. So first of all, one of the things CADCAM Wizards will do for you that's not really available anywhere else I've ever seen is it will figure out the ideal combination of cut depth and cut width to maximize your tool life as well as the performance of the cut. Those are your two most important variables along with which tool to use to set. And what's funny is even professional machinists often do that by rule of thumb and no real optimization. And at that point, so much of the game is decided that it's much harder to optimize. So you want to get a good balance of cut depth versus cut width. And there's some trade-offs. So let's talk about cut depth. The longer the cut depth, the more of the flute, think about how long your cutter is, the more of that flute is occupied in the cut. So to put it another way, if I use a little short depth of cut, right, and I do it in multiple passes to get to a deep pocket, well, I put all of the wear needed to cut that pocket entirely on that little short depth of cut. If I double that, I've spread the wear over twice the length of the flute. So spreading tool wear is a good thing. Your cutter will last longer. It won't have to work as hard, yada, yada. On the other hand, the dark side of a deep depth of cut is you have to work that much harder to get the chips back out of the cut, right? If it's a slot or a hole, it's got to potentially transport those chips up entirely by the helix. It can't fling them off to the side very quickly. And so that's going to require you to slow down your cut. So that's a type of trade-off you'll encounter. The width of cut has similar trade-offs. The smaller the width of cut as a percentage of the diameter of the cutter, the easier it is to get rid of chips, and the cooler the cutter runs, right? Because it's got that period of time during one revolution when the flute is exposed to air or coolant, and it has a chance to actually cool rather than before it starts picking up heat again by being back in the cut. So we're trying to balance these things in order to get sort of the combination that you want of best tool life and at the same time shortest time to get the cut finished. In other words, maximum material removal. So I hope that helps in terms of telling you what's going on. It's really hard to do it without something like CADCAM Wizard. It's really hard to get the optimum combination. Okay. This is also related to the question I got of how do you determine which machining method will give the most material removal rate depending on tool length to depth ratio. Again, that's what CADCAM Wizards does, is it tests hundreds of combinations using really smart artificial intelligence algorithms to find the optimal combination. Let's touch for a second on 3D surfacing, right? That's where we're going to cut out maybe a very ornate sign. You know, maybe we're making one for a winery where we've got not just letters, but we've got grape clusters and leaves and shrubbery, as the Monty Python crowd would say. It's all a bunch of irregular shapes. You're typically going to use either ball nose cutters or possibly V-bits and V-carve-it in order to make these shapes. And here again, you've got some really complex trade-offs on what size tool to use, what cut depth, and what step over or cut width is going to get that job done the fastest. A big tool can potentially get the job done faster than a small tool, except the big tool might not fit down in amongst all the detail. So typically you wind up, if it's a really complex design, you may wind up using more than one cutter with smaller and smaller sizes and smaller step overs in order to get the job done in the shortest possible time. And CADCAM Wizards uses some pretty clever algorithms to help you narrow down what you need to do there to get the best performance. Let's see. Had a question wanting to know about different types of wood and speeds and feeds. As we saw in the demo, there's a set of materials we can access. And let me just bring back the demo again. There's a set of materials we can access, and it's simple, right? For wood, it lists four things. It shows hardwood, MDF, plywood, and softwood. But of course, there's more to life than that. And if we want to get even better results, sorry, wrong button. We've got to go over here and we've got to have powerful turned on. Go back into feeds and speeds. And now there's a new button down here. It says alloy. It should say species for wood, but it says alloy because metals are alloys. And now we see that for hardwoods, we have hundreds and hundreds of different woods available here, right? I can come down here and go, well, I'm going to be cutting mahogany, all right? And that's going to fine tune what's happening to your feeds and speeds, for the exact type of wood that you're dealing with. The question goes on to ask about different cutter types, and especially cutter types for routers. And again, if we bring up our, let's see, I don't want to be in the tool crib mode because I want to show you all the different tool types. If I bring up the tooling menu here for all of our different tool types, and we'll start with end mills, you'll see there's a tip shape, also view it as geometry of sort of subtypes of end mill. For example, serrated rougher, you've probably seen these, are great for roughing. They can cut faster. They make smaller chips so they're easier to clear, yada, yada. But there's also a set of special cutters for routers. There's a down cut. And in a down cut, the helix is reversed so that it's pushing the chips back down in the cut. Now, why would you want to do that? And the answer is because if you pull up hard enough on those chips, you're going to splinter out the top of the cut. Whereas if you push down, that splintering is either eliminated or greatly reduced. So that's pretty cool. The negative about it is you typically cannot run as fast to feeds and speeds, but still, it's pretty darn cool if you're making something that cosmetically you want to make sure it doesn't splinter. Compression is like that, only it's sort of both. It pulls up from the bottom, pushes down from the top. So now, if you're cutting out a nice piece of, I don't know, melamine or some laminated product where both the top and the bottom have to be nice, then you want a compression cutter. So those are special cutters that GWizard handles for the router crowd. By the way, GWizard does way more different cutter types. I mean, we got annular cutters like rotor broaches, saws, lathe turning. I had a question about mill turn, And you get one tool menu, and whether you're on a mill or a lathe, you've got all your tools, including you've got all your turning tools. And yes, it is possible to do turning on a mill and milling on a lathe. So, it's handy to have that available to you both ways. Go back to my question list. Let's see, a question about ability to import tooling databases. We import Fusion 360 right now, and I do plan to add Vectric, Mastercam, and probably some others. It takes quite a bit of development work to do that stuff, so it'll be a little while yet, but that's definitely on the drawing boards, and it's going to be happening. Okay, let me go back to my list of questions here and see. Arturo wants to know if he can use the deflection slider to adjust the other parameters. Yeah, these sliders right now, they're just like thermometers. You can't use them to adjust the parameters. But that, too, is on the drawing boards. How do I handle a CNC converted SIG X3 with the stock 3/4 horsepower motor? The number of things you have to know to set up a new machine is pretty small. There's really only 4 questions: min and max spindle RPM, your spindle power, and your maximum feed rate. And if you want, you can click this request profile button, and it'll tell you how to get in touch and have us set up the profile. Now, with that said, I just want to let you know there's a more powerful version of this where you put a lot more information in. And GWizard can do some interesting things with that information. But these are more higher performance things, and if you're just a beginner, don't worry about it. Don't worry about it. Stick to the easy, right? Safe mode. What is safe mode? So safe mode is, we've all been there, right? You took a lot of time and money to get a CNC machine. You're ready to start using it, and the last thing in the world you want to do is break something, whether it's a tool or anything else. Eventually, by the way, you will get used to the idea that breaking a tool is not that big a thing. It can happen. Don't panic, and just make sure you figure out why it broke and try to avoid that the next time. But yet, we want safe mode. We want a margin for error is the best way to put it. And I mentioned all of those things that can happen that are basically skills you'll need to develop. And while you're still wondering whether you have those skills, just turn on safe mode. And what it does is it just radically scales back all sorts of different things in GWizard to make it really, really hard to screw anything up, even if you're not doing things quite right. It's like training wheels. Much easier to learn to ride a bike with those, and then you take them off when you're there, and life is good. So that's what safe mode is all about. It can do a lot stronger adjustment to the safe than the tortoise hair slider can. The tortoise hair slider is about making fine adjustments, and even more important, it's about adjusting between the difference of roughing and trying to get a fine finish. Okay, that's what the tortoise hair slider's mostly about. Okay, question. When you check HSM, which is high-speed machining, it's things like adaptive clearing and those kind of tool paths, why doesn't the cut width get reduced? Well, because HSM doesn't really have anything to do with the cut width. HSM, for those that don't know, is a tool path where you're guaranteed not to crash into a corner. And if you ever see what they look like, they're these loopy, kind of crazy loopy looking things. And it's all about when you run a cutter into a corner, the forces on that cutter suddenly jump up a huge amount. And it's like you just hit your cutter with a hammer. And, obviously that's not the best thing. And so if you can avoid that, you can run much faster feeds and speeds. By the way, the trade-offs that you want to make to maximize your material removal rate are actually not what a lot of people think. People are used to the idea that, oh, we got to run a real small cut width in order to get the best HSM results. And that's just not necessarily true. And that's another thing that CADCAM Wizards will do for you, is it will find the best trade-off even for HSM on cut width and cut depth. And I mean, just to give you an idea of what's possible, I had a gentleman post on LinkedIn, the article's up on CNC Cookbook somewhere, that he made $20 million bidding aerospace machining jobs just because of this type of feature in GWizard. Now, beginners and hobbyists could care less about that, but I'm just saying, that's what it's capable of for the professional. Let's see. Somebody notes that I didn't have a coating. What do we do for a coating? On the tool menu, there's coating picker. Okay. And you just tell it what kind of coating you have. There's like 5 different kinds. We can also handle diamond tooling, PCD, polycrystalline diamond, which some people view as a coating, and GWizard views it more as a type of material. It's like a whole new way of life. But that's how you can dial up a coating. GWizard will also tell you, this is something I didn't really spend any time talking about in the demo, but if you look at the tips row, right next to the tortoise hair slider, there's these tips. So if you ever look at a tooling catalog, they always have a technical section that tells you all the tips of how to get the most mileage out of their tools. But the thing is, who's ever going to remember all that darn stuff? I mean, there's literally hundreds of different tips. And basically, what this tips thing does is it comes in and it captures all that for you, so you have that feedback. So let's do something here that's kind of interesting. Let's say we're drilling holes. Okay, we got a twist drill, and let's look at what happens as we start to go deeper and deeper with the hole. All right, so now I'm at 1 inch deep, and my hole diameter is 1/4 of an inch. Now, mind you, hole depth is more about how many diameters than it is about the actual number of inches or millimeters that are involved. And so first thing it's telling me is my depth is greater than my stick out, and that's never going to work. So let's go ahead and change that stick out. Stick out's the distance from the tool tip to the collet where the tool goes into the tool holder. And then it's telling me, okay, we don't need to peck. Here's the optimum point angle on the drill bit for this material. And away we go. Now, if I keep going deeper, eventually it says, hey, that hole is too deep. You need a parabolic flute drill. Okay, that is a classic thing to know if you're an experienced machinist. But if you're not, or maybe if you just didn't even think about it, having GWizard here to tell you you need to switch to a different type of drill to drill a hole that deep can be very helpful. And it's literally got hundreds of these tips built into it, and it really helps. Let's see. I hope I got Gunner's question about what is HSM mode. High-speed machining. Let's see. Don't have any tool crib exports to CAM software yet, but that's coming too. I have several questions about the Mac, and I have to say I'm sorry to report we stopped supporting Macs near the beginning of the year for 2 reasons. One, we just had hardly any Mac users or even readers. I mean, CNC Cookbook gets 8 million people a year to visit the site. I mean, that's a lot. And only about 4% of that audience were on Macs. So that's conversely still a lot of people, but it's not that many GWizard users. The second issue was, beginning with Catalina, Apple made it just a lot harder to support Macs. and I could not justify the effort required versus the sales we were getting out of it. So we had to discontinue the Mac. We may be back at a future point, but right now we're just not supporting them. Somebody says VCarve uses a proprietary toolcrib format. Don't worry, guys. They talked to me. They've given me their software, and they've hooked me up with their format information. Speeds and feeds for plasma or water jets. You know, I've thought about it. Probably I will at some point. Probably not real near, just because I've got so many other things on my plate right now. Somebody wants to know, can I limit GWizard to look only at the end mills that I have? Absolutely, you can. That's done on the CADCAM Wizard setup screen. I can list tool cribs here. You know, like I can say, let's put I've only got one currently, the default crib, and I can say use cribs, and then CADCAM Wizard will only recommend tools that you actually have in your tool crib, which is pretty cool. Still going down the list. Cutting holes with milling bits. This happens in two ways. One, you can just plunge the bit, the end mill, and you'll get your hole made. And let me go ahead and switch this back over to powerful. Right. So let's go back to an end mill. Right, so my entry could be plunge, helix, or ramp. And what this is doing is telling me on this particular cut, if I want to make it just a straight plunge hole, I need to slow feed rate down to 1.1 inches a minute. Now the other way to make a hole with an end mill would be to spiral it out. And that's called an interpolated hole. And you can figure that out over here in CADCAM Wizard. You go over to the hole making, and you just say, I want to interpolate that hole. And it's gonna, you know, like maybe a 2-inch hole, because even if I had the horsepower, I don't want to spend the money to buy a 2-inch drill bit. You know, it's going to come back and it's going to tell me what type of hole I need and all of that good stuff. What kind of feeds and speeds. Let's see what else we got. We do import Fusion 360 tools. Minimum PC, yeah, anything that can run Windows 7. Doesn't have to be particularly powerful. I run it all the time on I have a little Surface tablet, and it's not a very powerful machine, works great. What else do we have? Don says he often gets different feeds and speeds when he double clicks, and I haven't personally seen that unless I changed something. So I guess I would encourage Don to send me an email, bob@cnccookbook.com, that has a case where he can demonstrate that, and I'll take a look and figure out what's going on. Let's see. Arturo wants to know about NaCO coating. The nano coatings are on my list of things to add. They're very popular for the CNC router crowd. They're a little newer generation of coating, and they'll give you a little higher performance. In the meantime, let's talk about another subject that I think is probably very relevant to this audience. One of the things that I changed when we go from powerful to easy mode is whether I present the so-called MFG or manufacturer's row. Now, let's go back to powerful just so you can see how this lines up. When we ran GWizard, initially, a fair number of people were thinking they had to enter something in the manufacturer's surface speed and chip load areas for each tool. And of course, that made it a lot harder because they had to go look up that information and yada, yada. You don't have to do that. You don't have to do that. In fact, I've even taken away the ability to do that in easy mode because GWizard's defaults are conservative, and you're not going to break a tool with the defaults. The manufacturer's information is useful for two things. One, you paid a premium price for premium cutters and you want to get all the performance you can. Great, no problem. Fill that information in. And two, I have this oddball cutter. It's not really exactly what you're showing on your tool charts, but I still have to figure out feeds and speeds. And I'm going to use it like an end mill, so I'm just going to plug in the manufacturer's data here and use an end mill, and GWizard will do the right thing. Now, in the case of these nano coatings, NaCO and so on, if you just plug in your manufacturer's numbers, you're going to get the full benefit of what the nano coating's capable of, and away you go. I do encourage you to watch the GWizard University video. I've got videos on every aspect of GWizard to find out how to go about entering the manufacturer's numbers, because GWizard does a lot of things, and this family feature is the main one that radically reduce the amount of data entry you might need to do and gives you a lot more power. So if you're going to mess with manufacturer's numbers, and again, this will be something I more talk about in a few weeks when I do the high performance feeds and speeds live stream, watch that video to see what the easiest way to do it. How can you tell when a cutter is getting dull? Well, you can look at it under magnification with like a jeweler's loupe or something, and if you see, visible chips, that's a problem. Sometimes you can run your finger over it and tell. Other times, and this is probably the more common thing for beginners, is you're going to notice the surface finish declines from what it used to be, and as it's getting more and more dull, it may start running a lot hotter than it used to, and eventually, of course, the final tell is it breaks. Okay, ladies and gentlemen, do we have any other questions you want to cover? I've kind of reached the end of the list here. Had a lot of good questions. I really want to thank you for teeing those up for me. Made everything interesting. Other questions? Okay. Thank you very much for attending. I hope you, if you don't already have a GWizard free trial, I hope you'll go ahead and try one out and sort of follow along the video. I will get it posted, and I will send everyone on the mailing list a copy of the link so you can watch it again at your leisure and pass it along. And if you have questions that you think of after we sign off here in a second, just email them to me, bob@cnccookbook.com. Thanks very much, everyone.